Well, good afternoon, everyone. It's me starting today.
Yeah, I
Um,
know. I feel so redundant.
yeah.
I feel like maybe I should just get off and walk away.
Well, good afternoon, everyone. Welcome back to another Technolive. I'm Dan, and with me, as usual, is Jack. Hello, Jack.
Hello, everyone. It's
Hello.
good to it's good to be here. It's all gone wrong, Dan.
It's
My
okay.
brain's melted today.
Well, we've started off with the usual in the usual fashion, so that's good.
Yeah, that's all that matters.
Exactly.
It,
Exactly.
it's just dealing with it switch around the wrong way. It hurts the brain.
So today I am in charge of the stream. So if we get numerous technical difficulties, it'll be my fault.
Yeah,
Uh,
blame Dan, not me.
blame
I'm innocent
me.
in this.
Blame me. It'll be a case of me just getting confused with buttons amongst other things. But we're actually going back today, aren't we, Jack, to something that we've done what feels like forever ago.
Oh yeah. Well, the
Because
thing is, last time you did this, I was on
I
holiday,
was
so I
gonna
didn't
say, I
have a chance to
thought
see
it
it.
was with Nia. I think I did the last one, wasn't it?
Oh yeah,
So
our
yeah,
regular one of us is away, so
yeah,
let's get someone.
yeah.
Yes, Nia.
So I had last time we did. So we're going to do some Unity today,
Hmm.
but it's going to be a continuation of what we did last time. So last time, for those of you who might remember, who are avid Techno Live viewers, we did well. Basically, we just programmed simple game. So we just had it move around. We had it. We built up a little platform. We had a little character, a little blobby character, basically moving around our screen in Unity. So what we're going to actually do today is build on that by adding in our very own AI, artificial intelligence.
Yeah, and this is kind of where things get a little bit confusing in computer science
Mm.
because we've had the term AI. That's not true. AI. Now we've had the term AI around for years, and it
Mm.
kind of means different things.
Mm.
So people have been researching this, since goodness knows when, since the 50s and so on. There's one version which talks about it's looking at making computers intelligent in different ways. So it could be machine learning, it
Mm.
could be neural nets, it could be things like that. That's one term of AI. However, it's also been used in the games industry and it's kind of been stolen because the game AI is not the same as, you know, sort of clever AI.
Yeah, yeah, exactly. So for those of you who don't or who have only just joined Technolive or who are unfamiliar with what Unity is, it's basically a game development platform. Really popular, isn't it, Jack? It's hugely popular.
Oh yeah.
Uh,
I'm just trying to think of recent games that have been used. Done you
yeah, there's some big names, aren't there? Really,
There are
that
big
have.
names that I can't seem to mention
Yeah,
to
yeah.
recall at this
We
moment.
we've got names. We don't know what they are, but we have names that have kind of used Unity as a platform to build their games. So it is really really popular.
All I can
Um,
think of is Odd World New and Tasty, but
mm,
that's not a modern. Well, it's a modernish game, but it's too obscure for anyone to
mm.
know. But that was done in Unity.
So as Jack was saying about AI, generally AI can mean lots of different things within lots of different sectors inside of computer science. But specifically, we're going to be programming a very, very basic game AI today, known more commonly as a seek AI, which essentially is where we're going to create a separate character within our game that's going to chase us. So this is quite popular mode of AI that you'll see in lots of different computer games. Now, of course, in big brand or big AAA games, you're going to see a lot more advanced Seek AI that's going to have a lot of complex kind of behaviors and stuff like that.
Mm-hmm.
Ours is going to be quite simple in the way that it works, but generally it's going to do the same thing, which is it's going to chase our character around our map.
Yeah. and I'm looking forward to this because I haven't touched AI. Sorry, I haven't touched Unity in years.
Mm.
We should probably mention who's given us a hand
I
with
was going to
this.
say, yes, so as part of this Technolive, in fact, what I'll do, Jack, is I'll switch to our scene, make sure it comes through.
Mm.
And so, as part of this Technolive session today, we need to say a very big thank you to one of my lecturers at Bangor University, Dr Llyr Ap Cenydd, who very kindly let me use his tutorials as a basis for this, well, the code that we're going to use today. So this is the code that he shared with me as part of my undergraduate course, and to give us a hand with our assignments and whatnot. So I was very grateful to him for letting me use this code today as part of this live stream. So thank you here, and to Bangor University, I guess, as well.
Yeah, of course. And yeah, one of the big important things about just working, with academics and as working in computer science in general is acknowledging who's helped you along the
Your
way.
sources, absolutely.
So yeah, you even when you go onto apps made by Google, you can sometimes find in the menu the credits for an app.
Mm.
And yeah, as we've got along the bottom here, we must credit Bangor University, who've well, thanks to oh, you'll have to help me with pronunciation. Sorry,
Dr Ap Cenydd.
Dr. Ap Cenydd.
There you go.
Yeah.
Yes.
So thank you very much.
Yes,
and,
absolutely. And he will be shared this video later as well, so that he can see what we've come up with and what we've been doing.
Oh, the pressure's on.
Yeah, the pressure is on. The pressure is on. So, what I've got on the screen currently for you all to see is basically a little demo of what we're going to make today. So this is Unity. I'm not going to talk much about how Unity works, since I kind of covered that in my previous live stream. So since we need to focus more today on the AI aspect of things, I'm going to kind of leave that for you all to go back to, should you so desire. But what we built last time, this is something that I've just built in my own time. I'll open up what I built last time in a second. But this is a basic demo of what we're going to make today. So I am this little blue blob here. This is my player. And over here I have my enemy. So these are our characters, essentially. And what I've got programmed, if I go on to here, is you can see that I have got something called a script. I'll make it a bit bigger. Now in order to build this script, I use Visual Studio Code, which is something, in fact, it might be easier actually if I change my window for you to see that. So let me just quickly flick over to a different window. Again, you'll have to excuse my slowness when it comes to this. I am.
We all know from when was the last stream?
There we go.
We remember that one of the streams we did where I was all fingers and thumbs, and we were talking for 10 minutes. I was trying to find the right button to switch the right view on.
There we go. So this here is our script to control our character. So we're using a language called C#. Now again, I am not going to talk a great deal about C# because I covered that in the previous video, but it's a type of programming language. Some of you might be familiar with the concept of if statements. You see those in Scratch and Python and so forth. And essentially all this code does is we've assigned a specific component to our character object in Unity. And that we're using that character controller component to control the direction that our character can move in. So when we press the W key, we move forwards at a specific speed. Now vector 3 is basically just, you can picture vector 3 as just kind of being like the vectors that exist within our Unity world. So we're using a special type of component, again I suppose you'd say, called Simple Move, which is built into Unity, which allows us to move our character forwards at a speed of our choice. So I've set the speed variable to 10, and that is the unit of speed that's the character's going to move. And then of course I've also got WASD, So those are my keyboard buttons that I'm using to control my character, and that will allow us to move forward, back, left, and right. So that's quite a simple bit of programming. Kind of
Looks
just
nice enough. I wish I'd known about Simple Move when I was doing Unity last, because I had to
Yes.
do that myself, the complex move.
Absolutely. Again, this code is compliments of Dr. Ap Cenydd, so thank you to him again for sharing this with me. And then this is an example of what we're going to be doing in a second. So this is, again, looks a bit intense, but it's nothing to worry about. We're going to start off with using another simple move, and then if we've got time we'll take it to be a little bit more advanced, but for the time being we're just going to start off with simple kind of just a simple movement AI system. So if I press play, let's hope it works. So I've started my game. You can see now that as I move, the purple blob is chasing my character, and it's doing that all on its own. So this is AI. Spooky.
It's weird that they call it AI when it's quite simple.
It is.
But I suppose the point of game AI is to make it seem intelligent when it's not, if that makes sense.
Exactly.
Like when you've got a character in a video game, that character doesn't have thoughts and feelings, but by the way they move and the way they act is meant to make you think they've got thoughts and feelings.
Exactly. It's about immersing you in the environment really more than anything, isn't it? So what I'm going to briefly do is just quickly switch the window so that you can actually see the one that we did last time. So Unity's going to shout at me now. Stand by. Apologies for the blank screen on the stream. It will come back, I promise.
Well, Unity. That's what you hope. You never know with Unity.
Well, no, you can pray. Have we got something? We've got something.
Oh.
Hopefully.
Oh, I was thinking about it. Well, this seems a perfect time to talk about the weather.
It does.
Oh, hang on. My screen's just caught up and it looks like it's loading now.
Okay, wonderful. So some of you might recognise this scene from before. We made this in the last Technolive session that we did, and currently all we've really got is a moving blob. Here he goes. So he can move around the world. Well, I say the world, it's a very small map, but we can move around, and effectively that's all we can do. So what we're going to do is we're going to now start by creating a new a new character, which is basically going to act as our enemy like we had in the other game. So what I'm going to do that is I'm actually going to right click over here in my hierarchy. So these are all of the different assets of the game. So I've got things like the camera, I've got the floor asset, I've got a cube object which is basically acting as the walls. So you can see I've got several of those. I've got the player object, I've got other cube objects which are obstacles. A good practice would be to actually rename these.
I was gonna say that's a bit
it's a lot of cubes. So good practice would be to rename them things like wall and obstacle and things like that. But for the purposes of this, everything is a cube.
Yeah. Just wish just hope you never have to try and find which cube you want to edit in a list of about 100 of them.
100 cubes, exactly. So I'm going to right click over here. I'm going to add a new 3D object. I'm just going to add another cylinder. I'm going to add another capsule, which is what we've got here, and at the moment it's kind of disappeared under the floor, so we just need to drag this up here, which is easier said than done.
The cool thing, the reason why capsules exist, which are just basically short sausages,
yes,
the reason why is because they are the perfect shape for testing video game objects. Because they've got the rounded bottom, which means they don't get caught going around corners.
Exactly.
easily. And they're kind of, you could argue they're kind of the shape of a human.
They are, basically, yeah.
Because, the feet don't have much area, the head doesn't have much area, but the torso does.
Absolutely.
So
So
it's a good shape for human characters.
it is. So we've got one capsule that's a player. I'm going to rename this capsule down here to being called enemy, so that we know that that's our enemy capsule. And I'm going to give it some colour because at the moment it's a bit bland. So I'm going to right click down here in the assets section, and I'm going to go to create, and then I'm going to find something that says material. And you can see here that I can now, I'm only going to make a very basic colour. So let's go with one that we haven't got yet. Let's go with pink. So I've got just a standard pink metallic looking material, and I'm going to rename this one, and I'm going to just call it enemy colour. So now I've got an enemy colour, and I'm going to drag that onto my enemy. So now we've got a pink enemy and a blue player, and they're both stationed quite comfortably, I'd say, within our little tiny map that we've got. Now, in order to make our enemy move, you'll notice that, well, you might have seen briefly in the script I just showed on the screen, we were using another character controller in Simple Move. So basically, we need to add another character controller onto our enemy object, because at the moment that enemy object is basically just a capsule. It's not going to do anything. It's got no script attached to it. It's got no programming. It's got nothing. It's basically just a solid obstacle. So what we're going to do, I'm going to click on the enemy. I'm going to go to add component, and I'm going to add on a character controller. So essentially,
I'm terribly sorry. That's my phone going off.
Oh, that's okay. So
his friends send me YouTube videos accounts.
Cat videos.
That goes on mute.
It's okay. I didn't actually quite hear it, so it's fine.
I was going to ask, where you right clicking to add? Where you clicking to add component?
So over on the right hand side of the screen, we've got an add component button.
It's right down at the bottom.
Yeah,
I see it
it's
now.
kind of hidden. Click on that, and then we can add a character controller. So now, essentially, what we've done is converted that very simple capsule into an actual character. So it's actually we can actually do something a bit more with it. So what we've got so far is a capsule. We've made it pink, and we've got a controller attached to it, a character controller, so that we can actually do something with it. Now, currently, the character controller, in order for it to actually do a great deal of anything, needs to be programmed, which is where we have that C# script coming in from earlier. So what I'm going to do is I am going to click again on add component, so on the right hand side of the screen. So make sure you've clicked on your enemy capsule. I'm going to click on add component, and I'm going to say new script, which is just down here, and we've got to give it a name. So I'm going to call it seek_AI, so I know that this specific script is now related to a seek AI, and that it's again like when we're programming things with or creating our assets and stuff. It's important that you name things appropriately so that you don't lose track. Not just call everything cube 1, cube 2, cube 3.
Or worse is when you call them all Bob.
Or all Bob. Or one of my pet peeves, calling Word documents Untitled 1, Untitled 2.
Oh my goodness. Oh yeah.
Oh dear. I can't be dealing with that.
Oh, and then you...
I don't understand what the minds of the people who do that, but there you go. We will pretend we'll gloss over that for now. So I'm going to create and add this new script. You can see now that I have got a CKI script. It has been assigned to the capsule, and it's appeared in my assets down here. Now I'm going to open this. I'm going to double click, and I'm going to open up Visual Studio. Now, I'd like to point out that when we're looking at let me just quickly flick my OBS window for you so that you can actually see the script in question. One thing I'd like to actually point out, that is the wrong one, is that when you are programming different things, okay, for some reason it doesn't actually brought up the window that I want, so please stand by for technical difficulties.
Where's the technical difficulties music?
Stand by for technical difficulties. Oh no.
Oh dear, that doesn't sound good.
We're having a fun moment, Jack. Okay.
Oh no.
We're reverting to plan B. Stand by, please. Where has the window disappeared to?
It's a game of find the window.
OBS has decided, do you know what, I'm not actually... Right, we're back onto Unity. And Visual Studio, that's not Visual Studio. Oh dear, Jack, we are not in a good way right now.
Oh dear.
It's okay, we can find it. Stand by for technical difficulties.
Not gonna have to quickly switch to making up a new stream.
No, it should be okay. I'm just going to...
I could launch into a lecture about vintage electronics if you like, because that's entertaining. My brain's fuzzy today.
It's for some strange reason not detecting the Visual Studio window that I've opened.
It might be looking for it might be scanning for the name of the first one you had opened, and so now I can't find a new one.
Yeah, because I closed the other one in the hopes that that would be a success. Unfortunately, right, stand by for intro scene. Unfortunately, it's just deciding, do you know what, I'm not actually going to show that window in OBS. Please stand by again, everyone. Apologies for the technical issues.
And the worst thing with OBS is when you go to fix something, well, you can't stop it showing what you're trying to fix.
No. Oh, we're there.
Oh, are we there? Are we there?
We're there.
Oh, excellent.
It's gone a bit... I'm going to have to do some... we're going to have to do a little bit of jiggery poker with our big technocamps.com, because for some reason the Visual Studio window is larger than the Unity one, but...
Oh, that's nothing to worry about.
All is well. We are back.
Yeah.
Apologies.
I no need to apologise. I was having fun just drinking tea.
Oh, there we go.
Because what else do you do when you got technical difficulties?
Exactly. All is now under control. Can you see on the screen currently, Jack, a blank C# script called seek_AI?
Yeah, that looks pretty blank to me. It's got two functions. It's got start and update. I assume we're going to be doing something on one of those.
We are going to be doing some bits and bobs. Has the word test appeared?
Oh, it's going to take a while for it to appear on my side, but just assume it has.
Let's assume it has. Okay. Now, some of this stuff is going to get a little bit intense because there's quite a lot to cover, but we're gonna get through it as best as I can. And even if it's the basic form of a CKI and not the more complicated, it will only find you within a certain distance AI, then that's fine, because we still will have achieved what we wanted to achieve. So all is well.
You say tense. That makes me think we're going to be attacked by. The AI you write is going to launch itself out of the screen and attack us.
The AI is just going to be too intense. So, this is the character movement script. I know you can't see it yet, Jack, but this is what we made last time during Technolive. What we're going to do, today is we're going to build up that CKI script. So the first thing that we need to do as part of building up the CKI script is we need to reference that character controller that I talked about earlier. So the character controller is what's going to actually allow our little enemy character to move around. So we need to reference that in our script and assign it to a variable so that we've actually got something that can link it to the game. The script can link it to the game.
So
So
Unity knows well kind of what the script belongs to, or
yes,
what the script's talking about.
needs to control essentially. So I'm going to make a character controller. So so this is the point I was going to make before the technical difficulties. There are lots of different editors that you can use for programming. I use Visual Studio Code because sorry, just Visual Studio, not Visual Studio Code. That's a separate thing. I use Visual Studio purely because it's really nice and has something called it's I can't remember the exact name of it, but it's basically, I guess, in its own way, its own little mini AI where it can predict what you're typing. There has a name. It has a name. I cannot remember
There's a
it.
branded name
There's a
in
branded name.
TeleSense,
That's the one.
but a lot of code editors do this now, which is really cool and just makes life so much easier.
It does. It does. So as you can see, whilst I've started typing out character controller, I've only typed in 3 letters, and Visual Studio is already saying, "Do you want to use character controller?"
Oh, you
And
won't like this, Dan, but OBS can't see that.
No.
So
Okay.
we can see you've
Well.
written cha as if you're trying to write cha cha cha, but we
Okay.
can't see IntelliSense. But what Dan's seeing on his screen is a little box which with all the suggestions of what he could possibly write next.
Yes. So at the moment, it's even suggesting to me what I would like to call my variable that's going to hold my character controller
Oh,
object.
that is very swish. That's
Yeah.
quite nice.
That's why I like Visual Studio. It's
Other
like
code editors are available.
other code editors are available, but I would recommend. Not sponsored. So I'm just going to go with controller, because that's just generally quite a nice name. And one thing that you have to bear in mind if you are programming in C# is you have to end most lines with a semicolon. It's one of those, Jack, that loves semicolons.
So yeah, it's C sharp, which means it's based off C, and C ends everything in semicolons, and so do all the languages that are based off C.
Absolutely.
So you get things like Java, JavaScript, and I've run out of things that are based off C. But yeah, they all end statements in semicolons.
There are even libraries in Python that use C as a basis.
Oh yeah.
So that's
C is one of the kind of oldest. Well, not the oldest, but kind of the one that's most stuff is based off.
Yeah, and it's still used a bit today as well, unlike lots of other old programming languages that aren't really. But so we've got a character controller. We've got a variable for it. The other thing we need to do, you might remember that for our player, we had to specify how quickly it could move. So what we're going to do is something, again, very similar to that, where we're going to make another variable called speed that's going to basically regulate the speed of our character. But we're going to make it something called a public float. Now, a public float is one that we can manually control within the game. So if I was to create something called a float, which is a type of a variable that can have a decimal point in the number that it's assigned to, if I was to make a float and just call it a float and not a public float, we would only be able to edit the value of the speed within the C# script. But by making it a public float, it actually creates its own little box within Unity that lets you automatically from within Unity edit the value of the variable. So it saves you having to come back to the script.
So, the public keyword, and a lot of languages do this, just basically says, okay, let anyone change this.
Yeah, absolutely.
Not just the file that we're writing at the moment.
Exactly. So I'm going to give it a speed of 7, and the only reason I'm going to do that is because at the moment my player is able to move at a speed of 10. So if I was to set the AI to be the same speed, we wouldn't really be able to escape. So to give our player a little bit of a head start, I'm going to set it to 7, just so that we can, but we can edit this later. Now, we also need to create some variables that are eventually going to allow our player to seek our enemy to seek the player. Now they won't make a lot of sense for the moment, but we need to have we need to create these as a means of allowing our enemy to follow paths basically within the map, because obviously everything within Unity works off of vectors, as I've mentioned. A lot of things work, not everything, but a lot of things work off of different vectors, and so we need to create variables to hold vectors that will guide our enemy character to our player. So what we're going to do, we're going to make some vector 3s, which is the most common type of vector I think used in Unity, to my knowledge. I might be wrong, but that's mainly what I used.
I would think you're definitely right there, because what I understand, and bear in mind, I'm not the best at Unity. What I understand a vector 3 to be is you got your forward and backward, you got your left and right, you got your up and down.
Absolutely.
The 3 directions.
Absolutely. So we've got vector 2s and vector 3s. Obviously, I'd imagine a vector 2 would be more applicable to a 2D game, if I was to make an assumption.
Most certainly, yeah.
And a vector 3s to a 3D game, which is what we've got here.
So as long as you don't use a vector 4, where you've got the 4th dimension of time.
Yeah, that might be a bit tricky.
Starting thinking nth dimension game design.
I mean, it might come one day.
Might come one day, yeah.
So, what I've done here, I've produced some variables. So, just FYI, all of these are variables. This is a variable, this is a variable, this is a variable, this is a variable, this is a variable. These are all variables.
I would just say what type they are by the what keyword we have in front of them.
Exactly. So, vector 3, vector to target, is, as the name suggests, the vectors that the enemy will need to take to get to the target. Same with the direction to target vector 3 variable. And then we've also got a float. So as I mentioned before, a float is a number that has a decimal point. That's, I suppose, the easiest way to describe it, isn't it, Jack?
Yeah, it's just point. Any number with lots of decimal bits.
Yeah. To hold the distance to the target. Okay. Now, there's one final variable that we need to make, and again, these will become a little bit clearer later on. We need to actually refer to the player object, because currently there is nothing to tell the enemy what object it's seeking. So we need to make sure that the enemy knows that it needs to seek the player object from within Unity, within our game. So what I'm going to create there is something called a transform. This again is a type of object within Unity. I won't deny that I don't know what the exact meaning of the word transform is, but it's a mode of referencing an object or an asset within it's a way of being able to reference something that exists within your game. And consequently, I'm going to give it another name, player. So that again, we know that it's referencing the player, so it's about appropriately naming your variables. I guess these would be classed as variables. They might have a more specific name, but generally speaking, I'm going to go with that they're called variables because they're holding a piece of data that we're going to use later on. Okay, so that's all we're going to need for now. You've mentioned, Jack, about these two methods, start and update. Oh, yeah.
So people, veterans of Technolive may have seen that I've, ages ago, did something on 3JS.
Yep.
3JS is a game engine that uses JavaScript instead of C#. C#.
Mm-hmm.
And basically what the update function is, and even Arduino does this to a degree, is it repeats forever.
Yes.
But every time a frame goes by on the screen, whatever's in the update function will happen.
Yes.
So starts when the thing starts.
Absolutely.
Update happens forever.
It does. So most of the time, what you aim for, and correct me if I'm wrong here, Jack, is about 60 frames per second would be quite a smooth running
Yeah, so a lot of games run at 60. However, we're getting into scary territory now where we're obsolete and old, Dan.
I know.
Things like the PlayStation 5 and the Xbox Series X and high-end, PCs,
Hmm.
they're getting up to doing 120 frames per second now.
Which is very terrifying.
It is. It's yeah, I don't even want to
Yeah.
think about that.
So basically, the more frames you have running per second, the smoother your game or your video even will be. So
Yeah.
it's quite
Um
it's a lot of processing when you think about it, isn't it? Because there's a lot of code here that the computer is processing not once every second, but 60 times.
exactly, and that's why these new consoles are so beefy.
Hmm.
Just as kind of a comparison, if you watch a movie at a cinema, unless it's a really fancy cinema, most likely it'll be running at 24 frames per second.
Gosh, really? That's quite interesting.
Yeah, because that's all the human eye needs to see motion.
Uh huh.
That's kind of a nice balance of few frames, but not, still smoothish.
Yeah. Yeah.
But for
Absolutely.
games where everything needs to be moment perfect to
Hmm.
match what you're doing on the controller, the more frames you get, the better.
Exactly. So typically you aim for, or hopefully aim for about 60. Um, you will find plenty of people on YouTube who have talked about how they've bought some old clunky laptop from eBay and they're trying to run modern day Minecraft on it and it's running at around 2 frames per second and and it's just really really unplayable. That is what they mean by frames per second. It's how many times, in this context at least, the computer is going to be running that update method down here. So the more times it does that a second, the smoother your game is going to be. So we need to focus to start with on the start method because we need to do one or two things when the game starts so that we can actually have our game run. The first thing we need to do is refer back to that character controller variable that we made earlier called controller by actually grabbing the character controller component from the game. So we're going to grab the we're going to refer to the controller variable and we're going to make that equal to a special bit of code from within Unity called get component, and within there we're going to use a pair of angled brackets and we're going to say grab a character controller open bracket close bracket semicolon. A lot of words there and a lot of different things. But what all this line of code is saying is that within that character controller variable that we've produced earlier, we are going to grab the character controller component of our enemy object. Did that make sense, Jack?
It does. Of course, just make sure you got your all the right number of brackets and punctuation and all
Exactly.
sorts.
That's the only finicky part of C sharp.
Yeah, it'll tell you off if you haven't, but it's good to get that right
Get
first
that
time
right.
so you're not searching through errors.
Mm. So what we also need to do is refer to the player object. So of course, like I said earlier, we've used that transform player. And I've just found a note that I've left to myself because I knew I would forget what transform meant, like I said. And I've actually written a note here to myself that says the position of the player within the world is what the transform stands for.
Ah,
So by
that makes a lot of sense,
mm,
actually.
yeah, so by getting the transform, we've created a variable of type transform, and that variable is going to hold the position of the player object. So the way that we do that is we'll say player, which is the name of the variable, is equal to, and again we're going to use some special Unity code here called game object, and then we're going to say dot find, and then inside of brackets and quotes we're going to specify the name of the object that we would like it to find. So in this case we called our player object, or our little player capsule player, so I'm going to type player dot transform. So effectively what we're doing here is we're taking that transform variable called player and we're assigning it the position of the player within the world. Are you with me, Jack?
Yeah, I am. So you're finding the player,
We are.
but then you're finding the position of the player.
We are. So we're
And then
getting...
you're giving that value, that position, to a variable called player.
Yes.
I'd argue that that variable might not be that might not be the best name for a
It
variable,
might not be the best.
but it does make sense. I
Well,
think.
we could rename it, actually. Let's do that. We'll call it player pos. That makes a bit more sense now, I think, doesn't it?
Yeah.
So we've now got a variable called... Our transform variable is now called player pos for player position, and we've given that the position of the player within the world. Okay, that's all we need to do to get it going. So we've basically got our player object assigned to a variable. We've also got our enemy object assigned to a variable. We now need to, in our update method down here, which remember is happening every single frame, we need to get the AI to constantly monitor and track the player's position, and then have the enemy move towards that position constantly throughout the game. So we're going to start making use of our vector3 variables that we made earlier, starting out with the vector to target variable. So we're going to say vector to target is equal to, and what we want to get is the player's position, and we want it to basically work out the distance between the player's position and the enemy's position, so that way we can calculate the distance that exists between the two. So the vector to the target is equal to the player pos dot position. So we're getting the player's position dot position, which sounds a little bit weird, but we're basically getting the positioning of the player, and we're going to subtract from that the enemy's position. So the way that we refer to a specific object that we're programming is by using the word this. So we're saying this as in the enemy is transform dot position. So to recap on what we're doing here, the vectors to the target, in order to calculate the distance between the two objects, we're taking the player's position and we're subtracting from that the enemy's position, and that then gives us the distance between the two. How does that sound, Jack, so far?
Yeah, so it's a little bit of maths, so it takes me a while to catch up. But yeah, it looks like you're taking the position of the player.
Yeah.
And then you're minusing from that the position of the enemy.
Yes.
And yeah, that works out the distance for you.
There we go. Now, what we need to do is do something called normalize that distance. It will just, so that it just focuses on the direction, and so this is a little bit confusing, but effectively, instead of Unity being quite focused on the distance between the two, we're going to have Unity focus on the direction, but to the actual player. So that way, we're not getting it confused with how far away it is and whatnot. We're just going to work out how it needs to get from where it is to the player.
And I'm assuming this is because Unity does that weird maths thing that lots of game engines do, of having sort of two values in one thing.
Quite possibly.
Like a vector 3, we said, was the 3 directions. It's also the 3 speeds.
Yeah. So
I think what you normalizing, you're kind of filtering out only the bits you want.
Yes, so what we're going to do is we're going to set that direction to target variable to being the vector to target, which we just worked out a second ago, and then we're going to say dot normalized. So basically, as Jack said, we're getting it to focus specifically on one thing, which is the actual direction, and not several different things. Now, finally, before we actually make the enemy object move, we need to actually get the distance. We actually need it to focus on the distance again, but get it to focus on the length between the two objects in question, and again, not start going off on a tangent, because currently we've worked out the distance between the two, but it's using various different vectors and whatnot. We need it to just focus specifically on the length between the two objects, and we're going to do that using a special function called magnitude. So we're going to go back to distance to target, and what we're going to say this time is that the vector to target is, well, using that magnitude function from before. So I'm going to go through all these again because I know there's quite a lot to take in there and it's a bit confusing. So first thing that we're doing is we're getting the vectors to the target, and to do that we are subtracting the position of the enemy from the position of the player. So that gives us the distance between the two, and it gives the enemy an indication of where the player is in relation to it. Then we need to work out the direction to the target, and to do that we use that normalized function. Now the normalized function will completely ignore the distance and just focus on the direction, so that we've got that specific thing covered. And then we do need to refer to the distance as well, but it only needs to focus on the length between the two objects, i.e. the enemy and the player, and not the whole kind of, various other vectors that exist. So consequently we're using the magnitude function so that we're just focusing on the length.
It's one of my favorite words, magnitude.
Yes, it's a nice word.
And it just means kind of bigness, or how much of something.
Exactly. So now that our enemy is now aware of where the player is in relation to it, we need to get it to move in that direction. Now, we're not going to have time today, unfortunately, to do the whole when the enemy reaches a certain distance from the player, it stops seeking it. We're actually just going to add a line of code which will forever have the enemy seek the player. Now, this is a very interesting AI. This next line of code I'm about to give you is very interesting, and the reason being is because you could place your enemy 4,000 miles away from the player and it would still seek it, because it will use these calculations that we've just produced to figure out exactly where the player is 60 times per second, and it will continuously move towards the player irrespective of how far away it is.
That's it's very much like something we've struggled with MakeCode Arcade. Because of course, when you get a enemy to follow a player in MakeCode Arcade, the enemy will always follow the player no matter how far away they are.
Exactly.
So, and yeah, if you do want to get it so it will only go towards the player after a certain while, all you have to do is say if the distance is less than a certain amount.
Exactly.
So we'll go for the simpler way today.
Yes. So there are various different strategies that you can use. You can basically create another variable which focuses on the distance to the target and whatnot, and focuses specifically on if the distance is, so as Jack was saying, if the distance is less than this, then consequently you can have the enemy seek the player. Alternatively, you can have it seek the player forever. But of course, we'll go with the simpler strategy today. But there are, of course, no doubt, plenty of tutorials out there that you could follow that would give you more of an idea of how to get your player from one place to another, as there are many different ways of doing what we're doing today. This is just one potential strategy. There are several others. This one is quite simple, which is why I like it. But there are many ways of doing it. But what we're going to do, we're going to use the controller variable that we created earlier, and we're going to use that simple move function that I talked about earlier. So simple move, which is basically just a way of allowing something to move around the world. Now we need to give it two things. We need to give it a position, or a vector 3, and a speed, because at the moment there is no momentum, there's no velocity to any of our to our enemy. It's just standing still. It knows exactly where the player is, but it's unable to move. So what we're going to do is we're going to say, right, you need to get to the direction of the target, and you're going to move at a speed of whatever we've specified the speed variable to be. So we multiply the direction to the target with the speed variable. So just to recap on what we've produced here, we have got a character controller object which is referencing which is called controller, and we've also got a public variable called speed, which is going to be how quickly our enemy can move. And we've also produced some variables here which focus on the position of the player in relation to the enemy and its distance, as well as a transform object which refers to, of course, the position of the player within the world. Now we've of course got this when the game starts method, which is basically at the moment grabbing the character controller component of the enemy, and it's also assigning a transform, aka a position, of the player object to the player pos variable which we created up here. And then down here we're doing a bit of maths in order to, the computer's doing a bit of maths to figure out where the enemy is 60 times a second, and whilst doing that it's continuously and forever moving the enemy towards the player at the speed that we specified at the start of our script. Does that all make sense, Jack?
Kind of. I'm thinking about dinner at the moment, so it's it's a little bit fuzzy, but yeah, I think that makes a lot of sense.
Okay, good. Now, I have got to quickly change windows.
Oh, fingers crossed, everyone.
Yeah.
Let's hope OBS behaves today.
Success. Now I have got currently an error telling me that the variable player pos of CKI has not been assigned. So we have to figure out why that may be, but we'll try and figure that out in a second. First things first, let's just okay, interesting. So that was fun. So the whole time that I was doing that, the game was actually running. And one fun thing about Unity is that anything you create when the game is running won't actually be saved.
Oh, that sounds good.
Thankfully, the script is fine, but the enemy object has disappeared.
So yes, it's just caught up for me.
We're just gonna we're gonna get that back.
Oh my goodness, yeah. It's meant to be a useful feature of Unity. You're meant to be able to change parts of the game as you're making it.
Exactly.
But the trouble is, yeah. Of course, as it's running, it's just going to undo not all that we did. It's just going to undo what kind of things we changed about the game, but not the files that Dan's created. So we've still got the material file. We've still got the script file.
Mm-hmm.
It's just a case of adding that all back in.
Exactly. Now, it's still giving me a little error, which is really generous of it. And it's saying,
It doesn't have a character
Yeah,
controller.
because it disappeared. So let's fix that.
I feel smug now.
There we go. So you can see that as I go back and forth along the wall, the AI is trying to seek the player, but it's trying to find the most direct route. And of course, because it's not a very clever AI, it thinks that it can go through the wall. It can't figure out that it needs to actually walk around the wall. But if I was to break it, allow it to go around the wall, you can see that it very speedily decides that it's now going to chase me around. But it doesn't quite grasp the idea of walls, you see.
And of course, this is the very simple one. You can go all sorts of fancy. You can start using different algorithms to find the best way to walk around the wall.
Exactly.
Or I think Unity uses something called the Nav Mesh that does that quite well.
The Nav Mesh is very useful because it allows you to effectively, quote unquote, bake things into your environment. So effectively, if you've got a Nav Mesh AI or attached to your AI, effectively the AI will the object as it's moving around will be able to figure out. It will know essentially this is an obstacle that exists in the world. I must go around it in order to reach where I need to go, as opposed to just constantly walking at it like my enemy AI does here with the wall.
Still, for what? 10 lines of code, that's a really nice effect.
It is. It's very effective. So that is how you program a very, very simple AI within Unity.
Of course, and yeah, it's simple enough that you can expand upon it, or you can you can make it different, you can change it around. Yeah, exactly. It's quite nice. I feel like I need to get back into Unity after seeing that.
It's quite a good one. It's quite a nice, simple script. Thank you again to Dr. Ap Cenydd for sharing that with me and allowing me to use it in today's live stream. And of course, thank you everybody again for joining in, and hopefully you enjoyed it. I know it was a bit of a complicated one this week, bit of a difference from our normal chilled live streams,
but we like to mix up, don't we?
We do, and so this is a more complicated one, but hopefully it all makes sense.
Speaking of variety, shall we mention a little bit about what's happening in the next few weeks?
Yes.
So, first things first. Next week, of course, as always, we've got another stream. I don't have a schedule made for you today because my Photoshop still doesn't like me.
Oh, that's fine.
I could use something else, but I've got all my templates set up, and but yeah. But we've got another stream next week. We'll see about the topic. Either we'll see. Depends whether I can sneak a snoldering. That's not a word. Seek a soldering iron in or not. But yeah, next week we might be doing glitch art, where we make some weird, trippy art, or we might be doing some interesting electronics. So either or next week. And then the week after, the week starting 4th of October, we have the clubs back.
We do have the clubs back. Isn't that exciting?
Yeah, so my club on the Monday is starting with Python Turtle for a little while. And we also have Dance Club on the Wednesday.
We do. So we're going to be doing some getting back into coding exercises, dusting out the cobwebs after the summer holidays, and basically doing a little bit of Scratch. So that's the plan for my clubs up until the October half term.
Yeah. So yeah, and unless there's anything else to mention, I don't think there is.
I don't think there is.
Other than, again, wonderful thanks to our sponsor for today. No.
Yeah, our sponsor for today's video.
No, we don't have we're not sponsored.
No.
But yeah, yep. I'm just going to say yep until you end the stream.
Yeah, there we go. Okay, yep. I shall end the stream. Yep.
Wonderful. Bye, everyone.
Thanks, everyone.